All right, let's dive right in. Welcome to This Explainer, which is essentially your step-by-step training guide on analyzing and condensing quantitative data. I am so glad you're here. Today, we're going to break down the actual mechanics behind the numbers you see every single day. The goal? To turn you into a master of statistical comprehension.
But before we jump straight into the math, I want you to think about how you currently handle massive, chaotic data sets. I mean, when you're staring down thousands of rows in a spreadsheet, let's be honest, human brains simply aren't wired to grasp all that raw information at once. It's overwhelming, right? We need a way to condense it, to shrink all that noise down into a clear, actionable signal. And that is exactly what we're going to figure out today.
So here's our roadmap for this masterclass. We'll start with a quick statistical derivatives training guide, move on to defining ratios, percentages, and rates, and then practice calculating parts and wholes. After that, we'll look at ratios over time, master hybrid ratios, and finally talk about applying your new skills.
Okay, let's kick things off with Section 1, our Statistical Derivatives Training Guide.
The absolutely crucial point to understand here is that these derivatives are the foundation of shrinking numbers down. Why? To make comparing and comprehending them actually doable for us. You aren't just crunching math for the fun of it. You're analyzing and condensing data to establish vital underlying relationships. That's the entire purpose of a statistical derivative.
Moving right along to Section 2, let's strictly define the big three tools we'll be using: ratio, percentage, and rate. First up, the classic ratio. A ratio simply shows how many times one quantity fits inside another. Generally, you're looking at the relationship between two quantities of the exact same kind. You've probably seen this written as A is to B with a colon, or just as a straightforward fraction, A over B. And keep in mind, depending on what you're measuring, that ratio can end up being greater than 1, less than 1, or exactly equal to 1.
Next is the percentage. You know, relative measures are just so much easier to visualize in our heads, which is why we constantly translate base ratios into percentages. It's simply a ratio expressed as a relative measure per 100. It's honestly a pretty brilliant magic trick, taking a totally abstract fraction and turning it into a metric that literally anyone can understand instantly.
And our third core tool is the rate. Now, unlike a standard ratio, a rate usually compares completely different things. That's why it's expressed using different units. Think about dividing total income by total population to find per capita income. Rates are intrinsically dynamic. They capture change, and they are almost always tied to a specific period of time.
Okay, let's actually calculate a percentage together using a super effective two-step process. Step 1, you pick one figure to be your base and divide to find your quotient. So that's your A divided by B. Step 2, you take that resulting quotient and you multiply it. But what exactly are we multiplying it by?
By 100, of course. It's the absolute most vital multiplier you need to memorize. The term percent quite literally translates to per 100. Doing this simple multiplication just shifts the decimal place, giving you that concrete relative measure we were just talking about.
Now, there is a catch. When we're dealing with demographic statistics, things like birth or death rates, we actually standardize the rate by dividing by a related number and then multiplying the quotient by 1,000. This gives us a rate per 1,000, which is totally standard practice. It prevents us from dealing with crazy tiny decimals and makes sweeping demographic data way more readable.
Let's jump into Section 3 and see how this works in practice. Calculating parts and wholes.
Here is a brilliant illustration of the distribution ratio, which you might also hear called the total-to-parts ratio. Say a company has 300 female workers out of a total workforce of 1,000. We want to find the ratio of that specific part to the whole. So we take our 300 divided by our base of 1,000 and reduce it down to a clean 3-to-10 proportion. Just like that, we've transformed a chunky head count into a crisp, easily digestible relationship.
Now let's look at a closely related calculation: the interpart and interclass ratio. Instead of comparing a part back to the total like we just did, here we're comparing two distinct parts against each other, within the exact same total. We just use one of those parts as our base. The classic example here is a population sex ratio. Instead of females to the total population, you calculate the number of females per 1,000 males. You're measuring one piece of the pie directly against another.
Moving to Section 4, calculating ratios over time.
What's really fascinating here is the stark contrast between the two main ways you can calculate time ratios. On one hand, you have a fixed base period. This is where you lock your calculation to a constant past year.
For instance, you might compare every single subsequent year's tea production strictly against the production from the year 1980. On the flip side, you have the moving base period. With this method, your base keeps shifting. You calculate the current year's data using the immediately preceding year as the base. Both methods are incredibly useful. It just depends on whether you're trying to spot long-term historical growth or track year-over-year momentum.
All right, Section 5. We are entering the big leagues now, mastering hybrid ratios.
This is where the numerator and denominator are measured in entirely different units. Because you're dealing with apples and oranges here, we can't easily express them as percentages. Instead, we calculate them on a per-unit base. This effectively transforms them into the standardized rates we use every single day. Think about driving 30 miles per hour, measuring output per hour in a factory, tracking per capita income, or looking at persons per square kilometer in a crowded city. These are all hybrid ratios. You are taking two totally different categories of data and mashing them together to create one profoundly useful metric.
Finally, Section 6, applying your new skills.
Honestly, congratulations on making it through this foundational training. By mastering these specific steps, from simple total-to-part distributions all the way up to complex, dynamic hybrid ratios, you've completely leveled up your toolkit. You now have exactly what you need to instantly condense and comprehend complex quantitative info in the real world. You're no longer just staring blankly at numbers, you are seeing clear, actionable relationships.
So, now that you have the mathematical skills to confidently unlock these numbers, the real question is, what massive data set are you ready to conquer next? Are you going to go uncover the next big market trend, or maybe finally make sense of your own company's chaotic analytics? Keep practicing these tools, and I promise you'll realize the numbers have been talking to you all along. Thanks for joining me for this explainer.